Hello, everybody. Welcome to this month's webinar for OPSWAT Academy. Today is a very special day. We have a guest from outside of the OPSWAT organization. For those of you who have not seen me before, I'm Medeiros, the product manager of OPSWAT Academy. And with us today, we have Karl Perman. Karl Perman has been in the industry for decades, and we are so excited to have some time with him to talk about really interesting aspects of critical infrastructure and cybersecurity. Karl, why don't you introduce yourself to the audience and tell them a little bit about yourself and your experience in the industry?
Okay, great. Hey, good morning, Nate. Nice to see you. So again, as Nate said, Karl Perman, I'm the CEO of SIP Core. I work a lot with entities as a consultant in the areas of regulatory compliance, so NERC FERC, as well as state and other compliance initiatives, and a lot of cyber and physical security as well, just overall risk. Enterprise risk is what I would say, enterprise security. Been in the power sector for over 20 years, about 22 years. Prior to that was in government service and law enforcement. And prior to that was in the U.S. Army. So altogether about 40 years, I'm getting old, but about over 40 years of security experience. And like I say, about 20 in the power sector. And that's my background.
Well, your extensive experience in the field is really relevant to the topic today. We're talking about legacy systems within critical infrastructure. So you started
older than me.
yeah. And you've seen these systems probably still in use today. And
Yes,
so
sir.
let's set the stage. There's a lot of people in the audience today that probably don't know exactly what the subject is that we're talking about, because why would there be legacy systems, older systems for our most fundamental infrastructure for our countries that really provide our way of life, our water, our power, whatever it is. And why now are we saying that the computer systems that operate these things are old systems? So first, can you set the stage as to why that's the case?
Sure. Well, it's like if you look around, I'll just start in general with critical infrastructure. You look at our bridges, our dams, our tunnels, you see most of them concrete chipping away. And just in your area, right? You've got the Bay Bridge, beautiful, brand new bridge. You got the older bridge right next to it, though. And then you've got the Golden Gate, which, is kept in decent shape, but you still see potholes. You see some areas where you're like underneath there at one of those parks and you say, hey, that looks pretty old. Well, it is pretty old. It is old. Same thing with infrastructure that's water, wastewater, as you said, gas, power. Many of these, I'll call them facilities, were built years ago. Some, 100 plus, some 50, 60, some over 20, 30. And what's happened is, just like you may have still a pole in your yard, a telephone pole or an electric pole. Many of that's underground now, but you still see those poles. Or the large transmission towers you may see. Those, you could argue, what's the lifespan on those? Maybe it's 20 years, maybe it's 30 years. Most of those poles, if you remember as a kid, the same pole is in your yard as you are, now an adult. So 30, 40, 50 years. Basically, what's become a lack of preventative maintenance, if you would, and become what I would call break fix. So when a bridge starts to really erode, concrete starts falling from it, you see a crew out there to fix it. Why? Because it's a life safety issue now. When a pole gets infested with insects or just starts to erode because of weather or the foundation, mud, whatever it is, concrete chipping away, then a crew comes out. Normally someone has to call on that, or they do a line inspection. They say, hey, this thing's eroding. They go ahead and fix it. So it's just simply it's a cost issue and it's a lack of, I think, overall resources. So people, money, etc., where many of these things that were on a preventive maintenance cycle have become break fix.
Right. I mean, if that bridge was built 50 years ago and it's still working, then why would you build a new bridge?
That actually is one that mentality of if it ain't broke, don't fix it is definitely still out there.
And that makes things a little more challenging when we'll get to the cybersecurity aspect of what all this means. But there is a different mindset when we're talking about these kind of materials, because if I get a laptop, I'm not keeping that laptop for 20 years. But if I build a wind turbine, then I want that to last as long as possible. And ultimately, there are computer systems connected to that wind turbine that is operating, managing, monitoring uh, all of the physical components and putting that into digital information that we can then use to manage and monitor those systems. But from what I've heard in the industry myself as well, is that oftentimes, there isn't a one size fits all software or computer system for things like turbines and dams, for example, or monitoring software for electrical grids even. There's more standardization there, but the point that I'm trying to make is that oftentimes these technologies that are put in place are built almost as a one-off or just in few instances, and there's not a lot of crossover. You don't have these big support life cycles that can just be globally applied from like a Windows machine, Windows 10 long-term service. So not only do you have these older systems, but you also have systems that people might not even know how to code for anymore.
Yeah, I think that's a really good point. I think that. Go ahead.
Oh no, I was just going to ask you what have you seen with that, and what have you seen with the challenges that come from this lack of unity in that sense?
Yeah, that's where I was going. So I think a couple comparisons. So you mentioned laptops. So with laptops, you basically have a Windows machine or you have a Mac. So two different operating systems, but relatively there's people very familiar with Windows, people very familiar with Mac, some very familiar with both. Not a problem, right? To hire people for maintenance, to code, those kind of things. As you said, with our systems that run the grid, we'll just talk about grid for now, but overall, we'll just say critical infrastructure, particularly SCADA, right? Supervisor control and data acquisition devices. A lot of those are legacy, but a lot of those also operate on different protocols. So communication, different protocols, closed architecture, proprietary software, those kind of things. It's becoming more open. There's several firms that have become, or OEMs, original equipment manufacturers, that become more open architecture, but there's still some of that closed proprietary architecture that's in there where if you buy, Karl's system, you're going to stick to Karl for the lifetime versus going to Nate's system. So that is prohibitive because if you don't know that particular operating system or that particular SCADA devices and that SCADA software and hardware, then you need to find people that have that. And particularly the older the system, a lot of times different protocols that have been used over the years, so less standard. It is hard to find. I mean, we're on a retirement bubble too, like a lot of different industries, but many engineers and instrumentation techs that have been out there are retiring. So now the young folks or the younger folks, I'll say younger in their careers, not necessarily in age, but more junior people in their careers, they've learned different systems. And then when they look at something that's 40, 50 years old, they're like, wait a second. I don't know what this thing costs. What is this thing? So it's that lack of experience, but also, again, another analysis many years ago, when we were putting in security systems, life safety systems into substations, I remember looking at all the bids and there was never any preventive maintenance. And I was like, why would you invest $1 million in a system and not have a preventive maintenance plan? Yeah, it's expensive. It costs several thousand a month. But I was like, that's kind of return on investment. Like if you're going to put a system in, why would you not have preventive maintenance?
Can you give the audience an example of what preventative maintenance would be?
Yeah, so basically you go out to, I would challenge you to go anywhere. Go down the street to your local mall. I'll bet you can find a security device, let's just say a camera, in the parking lot, attached to the building inside, that is either dirty, broken, like hanging
there,
or it lost power. Just same thing in a substation or a critical facility, if you would. Many of those security devices that I saw when I went out there were exactly that. The lenses weren't clean. They lost power. They were broken. They were pointed down. They were pointed up. They didn't have the right field of view. So when I say preventive maintenance, I mean going out there on a routine basis, monthly, quarterly, semi-annually, some frequency, and checking those devices to make sure they're working as they were implemented. So making sure that they work as intended on a routine basis. And many places to this day still don't do that.
Right. Yeah. And that's something that can be seen, we're giving examples of physical devices, and this same mentality and the same issues really do arise when we're talking about computer systems and the software that they're supporting.
Just go from there.
Yeah, we see that in the very same way. So let's actually jump toward that. Let's jump toward the cybersecurity elements of this. I think one of the most obvious challenges with a system that has been operating for 20 years, running on, a DOS device, for example, is that no longer can we install and operate modern anti-malware or malware mitigation tools on those devices. So what do we do about that? What are some ways that we can protect systems that are just inherently incompatible with ways that we protect our computer systems today?
Yeah, that's a great question. So, and as you said, that was just definitely, there's a nexus there that these old, like I talked about cameras as an example, are same thing, like you said, present with the hardware and the distributed control systems that we see in a lot of the critical infrastructure. As far as, so as you said, I mean, antivirus, malware detection, those kind of things, a lot of times they do not run on these devices, or they cause hiccups in the operating reliability of those devices. So many people, it's the same philosophy of, hey, if it's working, I'm not touching it. I'm not doing anything to it. I'm not changing password. I'm not doing any kind of antivirus. I'm not doing any kind of firmware push. I'm not doing any kind of anything. So
even the implication of making a few millisecond delay on some existing loop because you're adding a new security tool is a big deal.
It's huge.
Yeah.
And that's a great point you brought up, because IT systems, their criticality is critical to whatever operation they're doing, finance, operational, et cetera, et cetera. When you're dealing with SCADA systems, or what I'll say operational technology, which includes all the stuff that includes SCADA, energy management systems, all the stuff that drives the power and flows the gas and the electricity, all that. When you're talking about those, the criticality is actually second to the real time, right? The real time element of those issues is the most critical. So that real time factor is very important. Like you said, just milliseconds can cause a problem with a protective system. So again, I think the first thing is you need to do a vulnerability assessment yourself. So the entity has to do a vulnerability assessment to say, they have to realize that, hey, we've got some really old stuff. It includes these, almost like what we would call on the IT side, a business impact analysis. Same thing on the OT side, to say, hey, here's our most critical systems. Here's how old they are. And then talk about what the vulnerabilities are. And then you may not be able to do antivirus, malware, et cetera. But A, you should check out if you can, or employ another technology. And two, you could have alternative controls and mitigating what I'll call compensating controls. Like, okay, if this PLC, is susceptible to, the age and all that kind of good stuff, it hasn't been updated, it doesn't have, it's on old firmware, et cetera. Well, then we're going to lock that in a room that no one has access to other than this select group of people, because then that would prevent an outsider just toss a USB into it.
Once again, can you give an example to the audience of just a simple example of a PLC, so we don't lose them in acronyms? It's easy to do.
Yeah. So basically, with a PLC, programmable logic controller. So what I'm talking about is basically a computer that would this is the brains of your distributed control system. So basically, that PLC would control all the elements of that particular system, be it energy management system, SCADA system, et cetera. It's really the brains of the operation, if you would.
Yeah, and you can even see simple examples of these for the fuses that control your sprinkler system in your lawn. It's that transitional element from, hey, this is a digital input, to how am I going to turn that into moving a valve or moving, making my sprinklers turn on, things like that. So they're very specific brains for a very specific task most of the time.
And as you said, that PLC has many other instruments in it in what we call a distributed control system, which could be human machine interfaces, like Nate said, like a pump, digital pump operator, those kind of things it's the opposite of manual. So I always tell people like a thermostat. A thermostat, the old ones where you have to slide the bar or turn the knob, that's manual. The ones that like nest and you program, that would be kind of like part of a distributed control system and what I call digital. It's smart.
Digital, yeah.
Smart technology.
So going back on the acronyms, though, one did come up. I wanted to take a second to talk about that as well. You mentioned SCADA systems.
Mm-hmm.
So just in a few words to set the stage really for the audience and the environments that we're talking about, how would you define what a SCADA system is in critical infrastructure?
Sure. So first, the acronym, as I said before, supervisory control and data acquisition. So SCADA, again, has many different pieces to it, but basically is the entire operating module, if you would, with all the instrumentation that basically drives a particular system. Then again, the system could move power, it could move gas, it could move water, it could close and open dams, it could close and open valves, but it's basically that technology that operates that particular mission critical function.
Right. Yeah, that's good. Now, I know we're doing a lot of information for everybody in the audience. I'm sorry that there's a lot of acronyms, a lot of terminology here.
Yeah, sorry.
But it's important. It's important because to set the stage as to why we have these DOS systems, why we have these legacy, even Windows XP nowadays that are used prevalently for something that was deployed maybe not as long ago, but still a vulnerable system. There are so many elements around it that are critical elements, and like Karl said, that real time or even uptime, they can't really go down. So having something that's servicing hundreds, thousands of people, and it's working, the things that you can do to revamp or improve some kind of working system, it isn't just updating the software. It's connected to all of these actual real world physical things through these human machine interfaces, through these PLCs that are working as a unified system. And unfortunately, the way that vulnerabilities, when it comes to cybersecurity, they don't go away. So you have something that is an older system that releases a vulnerability, and that older system is no longer getting patches or updates. It's not like you can just put in a new computer, because then we're talking about that other situation that we prefaced earlier with, now you have older software that's operating this wind turbine that nobody knows how to code for anymore. So it's not like you can just replace it. You'd have to build it all from scratch. So Karl, I think this is kind of leading to something that I'd really like to talk about today with the legacy systems, and has kind of become one of the de facto security measures in how the heck can we even start to protect these systems, and that's through air gap networks. Mm-hmm. So can you define what the philosophy of an air gap network is, and really why it's so impactful to this entire situation that we've been describing?
You bet. So that's one of my favorite terms, I guess, air gap, because if I had, $100 for every time somebody told me that system was air gapped and it really was air gapped, I'd probably be in Hawaii today or something. Or somewhere, Bora Bora, somewhere good, right? But no. So air gapped really means network segmentation. So when you talk about air gapping, like say an industrial control system or your operational technology, that means that system is segmented from everything else. So no emails, no internet connectivity, no nothing. And what's happened is, with the advancement of digitalization, many people tie something from their information technology side into the operational technology side. So it could be historian, it could be some type of data aggregation tool. It could be, Wi-Fi. People put in Wi-Fi, they put in TCP/IP connections just for ease of communicating across networks. So it could be a lot of different things, but true air gap means true segmentation for that particular critical system from all your other systems, and particularly the internet.
Right. And so nowadays we have a higher demand for goods and services, just globally. The more people that we have in the world, the more demand there's going to be. And things that improve efficiency are going to be adopted. and the use of cloud technology, remote monitoring. So now we're having air gap systems that also happen to have cloud connections. So it's introducing more vulnerabilities, or really just a bigger attack surface area. So do you see policies or any kind of breaking point with you're working with a vendor who wants to deploy, or maybe they have an older existing system and they want to deploy a new monitoring tool? What is the process there? What's the ultimate decision as to whether or not it's worth it to open up that new potential threat vector?
Good question. I mean, I would say really there's no, that's $100,000 question probably, if not $1 million question. But there's no, I think, right or wrong answer or a particular answer that I can give for that. But it really is organizationally dependent on what you're looking for and where you're at. But I think that no matter what you're going to do for advancement of either data intelligence, like I want to make better decisions operationally with my data, or I want to put in some security controls, you're going to have to introduce additional digital devices into your environment. Because for data, you're going to need collectors. For security, you're going to need collectors. Right. So it's got to be collected and analyzed. So many people kind of get freaky, if you would, when it comes to, what do you mean I got to put a local appliance in my substation? Not happening. So then, well, okay, that doesn't happen. Well, then you're back to your Ouija board and candles, if you would, for your asset protection strategy. Not say, I don't know if that's good or bad. It's not. It's. I'd say it's probably not the most effective. But again, it really comes down to a business decision of how much risk appetite do you have on introducing and the maintenance of additional technology in order to support security and better operational data that can be used for decisions. But I think two facts are virtualization is here. It's been here for a long time. So many companies are not operating on just, one data center or one server. They've got multiple stacks and they're across probably multiple data centers. The second thing is cloud's here. Cloud's been here. So as much as people talk about on-prem is much more expensive to have from a maintenance and from a sustainment. So more and more things are going to the cloud, particularly common systems, right? So like Office, like a lot of repositories, like a lot of security systems, even, right? You get that on your iPhone or your Android. So we're there. Now, have I seen SCADA from an iPhone or an Android? Not yet. Let's talk in probably 5-6 years. And that opens up a whole nother realm of, oh, wow, well, what does that do for us? But technology is advancing very rapidly. So I think it's not a matter of if, it's a matter of when. And again, I think it's a matter of the business return on value, as well as, do you want to come up, to the next century, or you want to still be back in the 20th century, or 19th with some of these devices. So it's really, again, I don't think it's a matter of if, it's just a matter of when and how much, that you want to do. Like, I'm still, as you know, a purist when it comes to a lot of things like asset management and configuration change management. If you don't know what you have and the changes around it, then I wouldn't go out and invest in millions of dollars in a network monitoring tool, because how are you going to defend and protect what you don't even know you have?
Absolutely. And that's, I think, even the elements in between those as well. I think we'll get to that in a little bit, because I do want to talk a little bit the Purdue model and network segmentation and how that applies to it. But I did have a question I wanted to ask you before it left my mind. A lot of people in the audience today, a lot of people that come to our OPSWAT Academy are interested in potentially starting a career in cybersecurity, or making lateral movements, or looking at new aspects of the industry. And this concept of I'm going to secure a older system, it's not a common training path in many ways. In many cybersecurity academies, even looking outside of our own. So when you're seeing people that are up and coming in the field, are you seeing people that are being trained on these older systems, specifically on like DOS configurations, DOS best practices, or is there a more general approach to, hey, we know these are old systems, what are the best practices to support them around those systems? So what's the mindset with that?
That's a really good question. First, I just want to clarify something because I can't. You said Purdue, so I can't help but to make a joke because it's Thanksgiving. Remember, you don't want to talk about Purdue today because they're chickens. You want to talk about Butterball because they're the turkeys, right? So I know you said Purdue model. Let's talk about the Butterball model. So I couldn't resist that one, Nate. Sorry.
Right. Okay.
If you edit that out, I get it.
No, we'll leave it in.
Okay, so back to your question as far as training. I think it's entirely dependent on how that person is trained. We know that in this industry, there's a lot of OJT or on-the-job training, right? So I hire Nate, and Nate's like, my wingman for a year, 2 years. So you're going to learn on the systems that we have out in the field because you're going to be with me every day, and you're going to be learning from me, and you're going to learn on the instrumentation that we have out in our field. If you go through a academic path, you're likely going to learn on the latest systems. So you may have a class on overall communications and protocols and types of DCS and PLCs and all that kind of good stuff, but it's going to be very generic and it's probably not going to get a lot of details. The people that are learning the older systems would likely learn on the job from someone that knows them already.
Something very specific to that infrastructure facility. Right?
That's right. To that entity, to that facility.
And are you seeing any of this reflected in changes of regulatory compliance? Because, that's something that while changes do happen not incredibly quickly, over time, there may be some practices around air gap policies or egress and ingress data. Do you see anything developing in that reign of qualifications for cybersecurity professionals, or is this something that is really more of a, once you're in the industry and you start working with these systems, that's where the knowledge comes from?
Yeah, so a couple things on that. So one, the most mature regulatory model probably in critical infrastructure is on the NERC side, right, for the power sector, the electric utilities. So because that's been mandatory since like 2008. So several years. Water, they're talking about it right now. Rail, they're talking about it right now. TSA has a few things, but pipelines and such. But really, the most mature would be NERC, and on NERC, there are some security controls around what's called bulk electric system cyber assets, which would include your SCADA, your remote terminal units, your relays, all those kind of things, protective system devices. So not necessarily around, you can't have anything over X amount of years, but it's more about how do you have controls around those. So again, you may not be able to do particular like update and do patches every 35 days, etc. But you could have a compensating control. Like, hey, we lock them up, we put in, USB, physical lock, so you can't get onto them, those kind of things. But there's still something called a technical feasibility exception, where, TFEs are kind of been replaced by it per that cyber asset technical capability. So if you can make a case that that capability does not exist because it's old, the passwords, it doesn't accept, new passwords, it only works on one default password, those kind of things, you can still kind of write yourself out of those security controls. So there are some security controls that are out there, but it's still what I would call a work in progress. But definitely NERC has been around several years, and for the electric sector, I would encourage folks that are in any kind of critical infrastructure to take a look at the NERC SIP requirements, and that would give you a good fundamental foundation if you wanted to look at what kind of controls you have in place.
Right. This might be a hard question for you to answer since you've been into it for so long. But if the NERC compliance is an excellent resource for understanding just what government entities and regulatory offices are looking for with these kind of facilities. But where would one start? Where would one, if they wanted to start understanding what NERC compliance really is, and get some kind of digestible format? Is there one, or are they going to the NERC website? What's a good place to dip your toes as to the actual nitty-gritty policies?
Okay, so that's a good one. So a couple things. One, NERC does have a pretty decent, it's got a website with a lot of good information on there. Is the information readily findable and easily digestible? We could probably argue that.
You meant it's a lot. It is a lot of information.
It's a ton of stuff. So I tend to let folks know there's something called the one-stop shop when you look on the NERC and you go under standards. And that at least gives you a good breakdown of, wow, it's a lot, but it kind of goes into the different areas of both what we call the operations and planning side of NERC, as well as the critical infrastructure protection side of NERC. So the other thing is, I don't want to be self-promoting, but I did write a few books on NERC and SIP. They're a bit dated now; they're back on version 3, but that it's kind of, forgive the term, but NERC SIP for dummies, if you would.
There you go. Well, that's a good plug. I actually wasn't aware about that. So here
yeah, it's on Amazon. Yep.
There we go. We'll put that. What's the name of the book?
So there's 5, but the main one I would say is it's just called Critical Infrastructure Protection.
Great, and that is very relevant to us here at OPSWAT Academy. So good to know about that. So Critical Infrastructure Protection by Karl Perman.
Yep.
So let's go into it. So thank you, Karl, for that. Now let's jump back into we mentioned the Purdue model, but even more fundamentally, we kind of already touched on this in some sense, but the idea of network segmentation and air gapping, you could even argue, is just a form of network segmentation.
Absolutely.
But realistically, in most cases, you usually don't have a perfect lineup of events where you can have a system operating without touching any other system itself. Where you typically not walking into some room and printing out a report on a sheet of paper, and that's all I really need, right? And even that sheet of paper, depending on what's on that paper, you walk out with the room, could be classified as exporting of data.
And if that in your OT network,
right? Exactly. So typically there needs to be some kind of data transference, whether you're telling the system to do something or you're asking, what did the system do? And that's true for almost every sector in critical infrastructure protection. So we have this, there's a standardized model that was created by the Purdue University that, originally it was created so that these manufacturing facilities wouldn't fault, but it's been adopted as, for our mindset is cybersecurity and critical infrastructure. So we see a lot of these layers in which these different elements are. You have the enterprise layer, your email, internet systems, and then all the way down to layer 0 with the actual physical components. And in between those layers, we have these 0.5s. It's 0.5 zones. So layer 3.5s, we're going to have a security tool to protect these elements. And that's been a pretty typical approach with monitoring these things, but it's those areas of defining when that data is transferring from one zone, if you will, to another, or one segment of your network to another. And that's where you can do things. That's where you can monitor what traffic's going in and out, or I can, check for intrusion prevention. So are you seeing that there's just become an increase, a challenge increase with all of these systems now connecting out to internet-enabled devices, cloud IoT devices, IIoT, industrial Internet of Things, which we're seeing in critical infrastructure. This segment that we used to have working for a long time seems to be like there's more connections that are less easily funneled into those single points. So what's being done about that? What's being done of the fact that we cannot funnel things as nicely as they used to be? Are you seeing any trends with that?
Yes, I mean, and more technology is coming in as we speak. But the most traditional, or kind of one of the most prevalent examples of that would be what NERC has tended to call. Now they're moving to more of a security layer, but let's just go back to kind of what has traditionally been called, notwithstanding that the standards are coming up in 2024, is what we call electronic security perimeter. So basically put your crown jewels, your critical systems, in that electronic security perimeter. Then what you'd have is outside that ring, I wish we had a whiteboard, but then outside that ring, you basically have a secondary ring, which you would call security zone, enhanced zone, something like that, supervisory zone. But basically, as you said, those devices are still critical, but not as critical, not the crown jewels, right? So your SCADA, your energy management system would be in that electronic security perimeter, the most inner-centric ring. And then that next ring would be kind of your, what I would call enhanced network, where you could have security devices, historian, those kind of things. And then as you go outside that ring, kind of to match up with your layered approach, or they're on the Purdue model, your I call segments, layers, basically the tower. So same thing, like like I think of things as a circle. Then as you go outside and get more circles, those would then lead to the most outer circle of being your overall enterprise technology.
Yeah.
So you basically segment, as you said, you segment your most critical systems by layer, and then you protect those layers through
firewalls,
domain controller, terminal server, whatever they are. There's a lot of different things out there. That's been the most traditional. Now, as you know, what's come more prevalent is software-defined networks, and what I would call, I can't think of the proper name, but I call them like network-defined networks almost, right? Like zero trust.
Network soups.
There you go. Yes. So where you define what's in that network and who gets into that network, and then you lock that down. So it's the same type of perimeters, but they're guarded, if you want, or protected by these newer technologies that are referred as software-defined networks, the perimeters, etc.
Software-defined perimeter. Yeah. The idea being that we can no longer rely on this physical representation of what we're used to in the diagrams, where we
That's right.
Yeah, one section within a bubble and another section within a bubble. So, even just the concept of cloud computing itself, I mean, that's a good way to think about. Now you have to find new ways to secure things, because you're dealing with systems that are maybe even load balanced across multiple regions, multiple facilities. They're all interconnected now. So, what are the areas that we can secure? And actually, that leads right into this next question I have for you. We've been talking about these legacy systems. We've been talking about, and even touching on why it's a big deal is the vulnerabilities.
Yes.
So they're easily hacked. They're easily broken into. There's malware that's been around for so long that can affect these things. And now we're dealing with an environment in which we can't keep them as nicely packaged up. We do the best we can to keep them away from other systems. And that's through air gapping. So I wanted to ask you, what are some standard security practices that we're also doing, in addition to air gapping, that is protecting these super critical yet vulnerable systems?
Sure, you bet. Well, as I mentioned, complementing cybersecurity controls with physical security, right? So if you can lock these things down in an area where only certain people have access to them, and also I think the cleaner the area, the better, right? Because a lot of these systems have been traditionally out there in the middle of a plant that gets very dusty. Heat, cold could be a factor, all those kind of things. And as we've seen in the industry, I don't want to talk about extreme weather because that's a whole nother, kind of area that's become a big concern. But definitely weather is a concern in some of these instruments. The older they get, it's like me, right? The less I like extreme weather, the older I get, right? Too hot, too cold is not good, right?
Right.
So same with these systems, they become temperamental, if you would. So I think that one, that locking these down from a physical security standpoint, and two, I think again it comes to starting somewhere. So figure out what the vulnerabilities are and then have a life cycle replacement plan. Because the bottom line is these are going to have to be replaced at some point. And I think the old, break then fix mentality or methodology, I try to steer people away from that. So then at least it may take you 5 years to replace everything, or maybe even 10 or 15, but at least you've started down the journey of, fixing your most critical, your most legacy systems and the ones that are most critical. Goes again to that kind of technology impact analysis and figuring out what's the oldest, how critical are they, and then coming up with a life cycle plan to get those replaced. So I think it's those compensating controls. And then I think also to take a look at some of the newer technologies that are out there. So there's, cleansing stations, there's enterprise versions of those to make sure that you don't, because a big factor of these is someone takes in a laptop or removable media and plugs it into something, and all of a sudden they create an outage on that particular individual electronic device, like a relay or the remote terminal unit, and then it causes a hiccup in the entire DCS or the protective system.
You brought up something that's related to this, where we're working toward replacing with new technologies. Now, are you seeing anything different with the way we're implementing technology now to make it more adaptable, or in 20 years from now, in 2043, is there going to be somebody hosting a webinar saying, yes, we're still dealing with technologies that was implemented in 2023 and finding ways to support those legacy technologies? Is this going to be a perpetuating issue for eternity, or are there things being put in place to allow for more updates, a different mindset in how these critical technologies are being placed?
Well, God willing, hopefully you and I will be talking in 20 years. And unfortunately, I think that, yes, we'll still be talking about legacy systems. I don't think it's eternity, but...
Well, let me rephrase. The legacy systems that we're replacing things with. Is there a mindset in that it's not some proprietary technology? Is there anything being done to say there's going to be a roadmap for support life cycles for these long-term plans for 20, 30 years down the road, that we can replace them, that they're using more standardized code bases, they're using more standardized hardware, or is it just the latest and greatest of these old systems in a new way that's going to have the same problem 20 years from now?
Yeah, that's a great question. That's a great question, Nate. So thanks for clarifying that. I think, well, I know this. I still see a lot of institutions or entities that do not have a life cycle for operational technology. So you can bet they have a life cycle for their laptops, 3 years, 2 years, 4 years, whatever it is. But when they're putting in a new remote terminal unit, when they're putting in a bank of new relays, when they're putting in a new SCADA system, I don't hear anything about a life cycle. I mean, frankly, normally what I hear is, I wonder how long this thing will last, which then kind of causes me like, are we talking like 30, 40? Like what's the baseline? And it's usually honestly like 20 years plus. I mean, as you know, anything that's operational technology, it tends to have a higher cost than something information technology wise, just because people know it's critical infrastructure. So I think that, yes, there's more open technology going in. So it may not be the same exact, at least it's somewhat opening up the closed architecture so more people are educated about it. But I still do not see the advocation or wide adoption of life cycles for components of what makes up our operational technologies.
It's very interesting.
The question with a yes or no, unfortunately, based on what I see today, the issue will continue until we get those until it becomes like, hey, Nate, when you get a new laptop, you're going to be getting a new one in 2 or 3 years.
Right.
So that I say, Nate, go out there and install that. Please, we have an RTU to install, and you install it. You'll know that, okay, 5 years, I'll be coming back. Right now, the time that you'll come back is when that thing breaks.
And it's relevant too, because people that are looking, we have people in the webinar, like I mentioned before, that are potentially looking for a career path. this is going to be something that is going to be in demand for a long time. There's going to need to be people that can secure systems that are not modern, that are barely hanging on there, but super critical to everybody. So this is not something that's going away anytime soon. And that's really what I wanted to draw out with this question, that this isn't just some old issue that we've dealt with. This is kind of systemic in the way that our critical infrastructure works, in the way that these are.
I mean, cybersecurity is a huge growing field, right? And who knows what you want to believe, but we're definitely sorry. You could read some studies say we're millions of people short. I'm not sure about that, but I know we're thousands of people short. And even within that, that's just cyber. In this space, in engineering technologies, operational technologies, it's even less people that are qualified in that area. So I tell everybody that has, they come to me and they say, hey, my kid wants to go to college, or they were going to college. What do you think? I'm like, well, if you want them to make, decent living and have something that's going to be here for the next 30 years, take a look at OT. And they're like, what's that? And I have to explain it. And they're like, wow, well, okay.
Yeah, that's the point. They never heard of it before. And
they never heard of it before.
That's why there's people that we need in the industry.
Well, there's a lot of schools that teach this stuff either when you look out at engineering schools and such.
So yes, to the audience, if you haven't already, enroll for OPSWAT Academy. We have lots of courses on OT cybersecurity. You can get a sense as to the introduction of what these concepts are. We highly encourage you to take those courses. Karl, I'd like to leave you with one more question here before we sign off for the day. And really, with your experience in the industry that you've seen and the trends today, do you have any comments for us for what you see for critical infrastructure protection in the near future?
I mean, again, you know that I'm kind of, I believe in kind of a systematic approach to infrastructure protection. So again, what I would say is what I've been kind of, evangelizing for years, and I know you, OPSWAT Academy, believe in this too, but basically, know your assets first. Do an asset inventory and figure out what assets you have. Also, introduce some type of configuration change management program, because those assets are going to change, and the firmware, patching, except the interconnection of those devices is going to change. And then lastly, to your point, come up with an impact analysis of what are your assets, what are the common technology or vulnerabilities, and then what are some of the mitigations that you can do? Even on the legacy systems, again, there are compensating controls we talked about: physical security, software-defined networks, cleansing stations, all those kind of things that are out there that you can still use. So again, it's know your assets, have a configuration change management system, and then have a vulnerability assessment and have a plan, a roadmap of compensating controls to get that done.
There we go. There's always going to be people working on keeping the world safer, one critical infrastructure facility at a time, no matter how old those systems are. Karl, thank you so much for your time. It was a great session. Great having you on. I really appreciate your time on this call, and everybody in the audience, thank you for joining. If there was any questions that we didn't get answered in the Q&A sections, then we'll make sure to follow up via email. All right, Karl, thank you very much.
Happy Thanksgiving.
You too. Bye.
Bye-bye.